Hey guys, this question asks, which of the following actions will not induce a current in a loop of wire placed horizontally in a vertical magnetic field? And I've went ahead and draw that scenario out for you. We've got the magnetic field pointing towards the top of the page, in other words, vertically. And then we've got the loop of wire placed horizontally. You're kind of going to have to spatially imagine that. And because this is the solutions guide, you already know that the answer is B. But I want to talk to you first about why the other three do cause a change, do cause a induced EMF, and then we'll talk about why B does not. So in order for an induced EMF to occur, or an induced current to occur, we need to have a change in magnetic flux. And here we have the equation for magnetic flux, and you see that you can do three things that cause a change in magnetic flux. You can mess around with the magnetic field, the area of the loop, or the angle of incidence. And so option A changes the area of the loop. So if you were to make the loop smaller or bigger, that would cause a change in magnetic flux. Option C, spinning the loop of wire around the horizontal axis. This one's tricky to imagine, but let's say we put a horizontal axis there, and then you were to spin the wire. Again, this is really tricky to point out, but you were to spin the wire around that axis. You would at one point the magnetic field would be completely attacking the inside of the loop, and then as it continues to spin around, once it gets up to 90 degrees, then it's going to be attacking none of the loop, because all of the space inside of the loop is going to be completely vertical with the magnetic field. And then as you continue to spin it, you're going to get eventually back to attacking the entire inside of the loop. And so you're changing the angle of incidence is what's happening. And so that would cause a change in magnetic flux and thus induce an EMF. And then D, increasing the magnetic field, well, that would also cause a change in magnetic flux and therefore induce a current in the loop of wire. Why does B not cause it? Well, moving the loop perpendicular to the magnetic field. So perpendicular magnetic field, in other words, moving the loop horizontally, because since the magnetic field is going vertical, if you were to move it horizontally this way, left and right, you're not doing anything that's going to cause a change in magnetic flux. You're still hitting the same entirety of the loop. You're not causing a change in the angle of incidence. The area of the loop isn't changing, nor is the magnetic field changing. So therefore, you're not causing a change in magnetic flux, and because there's no change in magnetic flux, there's no way of getting an induced EMF.